Okay, so let's go over solving some logarithmic and exponential equations that are a little more challenging, okay? Let's take a look at this first one. They're asking us to solve this particular logarithmic function, right? And if you recall from some of the previous examples we did, we need this written as one logarithmic function, not two. So, since there's an addition sign between them, how do I recombine this addition problem? Excellent, into a multiplication problem. So, my next line will look like the natural log of x times the quantity of x plus 2 equaling 4. And yes, I know some of you are like, let's distribute. Great, let's distribute. So I would have x squared plus 2x, right? Okay, and now you're trying to solve for x, right? You're trying to get to the x and what's in the way. That's right, the ln is in the way. So how do I get rid of a log? Excellent. You've got to take the exponential of both sides, don't you? So here's the deal. Remember, ln is the same as log base e, right? So when you take the exponential of both sides, you have to take the exponential e of both sides. So the base e and the log base e will cancel out, and you'll be left with x squared plus 2x equals e to the power of 4. Now, I want an exact answer. So we need to stay off the calculators. Something else here, do you notice there's an x squared? Which means you're going to need to set this equal to 0. Because to solve a second degree equation, you either need to factor it or you need to use the quadratic formula on it. One of the two. So, regardless of which one you're going to use, you're going to have to subtract that e to the 4th on both sides. And now, I don't know how to factor with that e to the 4th, so I'm going for the quadratic formula. I know that in this case, a is equal to 1, b is equal to 2, and c is equal to a negative e to the power of 4. This ought to be fun, guys. Follow along. Okay, so we'll have x equaling the opposite of b, so negative 2, plus or minus the square root of b to the power of 2. So 2 squared is? Good. 4 minus 4 times a, which is 1, times c, which is at negative e to the power of 4, all over 2a, which would just be 2. Do you agree? Okay, keep following. So we'll have x equals negative 2 plus or minus the square root of 4 plus 4e to the power of 4, all over 2. Do you agree? Okay. So now, inside this parenthesis, since they don't want me to give them a decimal answer, they want an exact answer, I need to stay off the calculator. So here's the deal. What I am noticing is that there are perfect squares under here, but since they're attached by addition, I can't look at them separately. Remember, if you want to look at things separately, there has to be either multiplication or division between them so you can break things apart. So what I'm noticing is, since both of these have a 4, I'm going to factor a 4 out. So here's what my next line will look like. I'm taking a 4 out, which leaves me 1 plus e to the power of 4, all over 2, right? Which technically means I can look at this as the square root of 4 times the square root of 1 plus e to the power of 4, all over 2. Agreed? Because now that there's multiplication in between here, I can split these guys apart. With me? Okay, so you know the square root of 4 as well as I do. What is that? Yeah, that's 2. So I have 2 times the square root of 1 plus e to the power of 4 over 2. And I'm noticing, since they all have 2's, right? The numerator, I can factor out a 2, and I'll be left with a negative 1 plus or minus this square root all over 2. And I can cancel these 2's out, can't I? Right? So that means we'll have x equaling negative 1 plus or minus the square root of 1 plus e to the power of 4. Well, that's a lovely answer. But there's 2 answers there, aren't there? Okay. So one answer is negative 1 plus this square root. The other one is x equaling negative 1 minus this square root. Agreed? Now remember, since my original problem had a log in it, I have to make certain that my answers, when I take the log of them, I'm not taking the log of a negative number. Because if I'm taking the log of a negative number, we're in trouble. I can't take the log of a negative number. Because remember, the domain of a log is greater than 0. So, you can get your calculators out, but we're going to walk through this. And I'm actually going to tackle this second one right now. This is a negative 1 minus this. You know this one's going to be a negative number, right? This first one asked me to take the natural log of just this x. Can I take the natural log of a negative number? Nope. I don't care if it worked in the second one. It's not working in this first one. In this first one, I'll end up taking the log of a negative. So this one isn't going to happen for us. Now, let's look at the first one again. What I need to make certain of is, first all of this is positive. Well, help me out. Under the square root, 1 plus e to the power is going to be positive, yes? I need to make certain that this is greater than a negative 1. Well, 1 plus any number, 1 plus any positive number is definitely going to be greater than a negative 1, right? What I just need to make sure of, it's greater than a 2. And yes, go ahead and punch it into your calculator, but this one will actually work for us. This will be a positive number, greater than 2, and this will be my final answer for this problem. Negative 1 plus the square root of 1 plus e to the power of 4. And if they want a decimal answer, well, I'm sure you've plugged it into your calculator to verify, and now you've got the decimal answer. Good? Okay, so recap. I had an addition of 2 logs. I needed to recombine them so I could work with 1 log, and it would combine to multiplication. This is a log base e. Natural log is log base e. And to get rid of a log, I have to take the exponential of both sides, which left me with this wonderful second degree equation. And I had to set it equal to 0 in order to solve it. And in this case, we went with the quadratic formula because we can't factor that thing with an e to the power of 4 there. And here is our work for the quadratic formula. Good? Okay, so hang in there. I got another brain teaser problem for us to solve. Okay, so let's look at this second problem. This one is an interesting looking problem, okay? Here's something I'd like to draw your attention to. I'd like you to draw your attention to the fact that this has a power of 2x. This has a power of 1x, doesn't it? Okay, I'm going to do a little bit of a rewrite on this problem, and hopefully this helps. So we said this was the power of 1x, agreed? So I'm going to do a little bit of a rewrite to help us out. I could rewrite this as 2 to the power of x, the whole thing squared, couldn't I? Because if I multiply those exponents, I get 2x, don't I? And that's exactly what that is. Agreed? Remember, through parentheses, you multiply. So you multiply an exponent to an exponent. I would get 2x, which is exactly what was here. Yes? Okay, so the second one, I have 2 to the x to the power of 1. Same thing. Multiply, I get 1x, don't I? Good. Minus 12 equaling 0. Yes? Okay, So notice something. This first term has a power of 2. The second term has a power of 1. The last one is just a number. Technically, this would be a second degree equation. And you're like, that kind of doesn't make sense. It does, except you're used to seeing an x in these parentheses, and I have a 2 to the x in these parentheses. So here's what this is telling me. It's telling me my variable is not just x here. My variable in this case is 2 to the power of x. So when I look at this, I'm going to look at the coefficients. What's the coefficient in front of this variable? That's right, it's a 1, because there's a 1 in front of that parenthesis. Remember, the parenthesis is our variable. What's the coefficient in front of this middle one? It's also a 1. So I have a 1, and a negative 12, don't I? Those are my coefficients, right? So here's the thing. This could be factored. Like, how do you do that? Okay, so let's think about this. If we place 2 parentheses, what's my variable again? 2 to the power of x. So 2 to the power of x is my variable. And if you're like, wait, when you multiply these together, what happens? Well, 2 to the x times 2 to the x, what would you do with those exponents? Since the bases are the same, you would add the exponents, which is why you would still get 2 to the power of 2x. So this works right here. And when you factor, I have to get a negative 12 on the back side, don't I? Remember your magic x? You need to get a negative 12 on this last number, but you need a positive 1 in the middle. So what are those numbers? Yep, a positive 4 and a negative 3. Won't that give me a negative 12 and a positive 1 when I add them? Yes, it will. So interestingly enough, this thing factors. As interesting as this problem looks, this factors. I just have to wrap my brain around the fact that my variable is not just an x here. My variable is a 2 to the power of x. Got it? Okay. So now, after we factor, don't we set each one of these equal to 0 and solve? So the first one, I'm going to take 2 to the x plus 4 and equal it to 0. We're going to solve it, right? So that means 2 to the power of x equaling a negative 4. So I need to get rid of the base 2, which means you've got to take the, great, you have to take the log base 2 on both sides, don't you? Which means my next line will look like x equaling log base 2 of a negative 4. What do you think? We did everything correct, didn't we? But can this be an answer? You're right, it cannot, because I can't take the log of a negative number. We spoke about that in previous problems that we solved in the domain of a log. We can't do this. This was one of the answers, but this answer cannot be. Good? Okay, so let's look at the other one. I have 2 to the power of x minus 3 equaling 0. I'm going to move that 3 over, right? And then I've got to take the log base 2 on both sides so I can get the base exponential base 2 canceled, which leaves me x equaling log base 2 of 3. Is this a good answer? Yes, it is. Cool? Good. And you're like, all right, I need another problem. We're going to do another problem, okay? But let me write something down. So right here, I mentioned the 2 to the x is actually our variable, isn't it? So you could have almost looked at this problem like, instead of 2 to the x, maybe just a y to the power of 2 plus a y to the power of 1 minus 12. I could have looked at it this way. And this one you know very well how it factors, don't you? Which is exactly that line, isn't it? And then I have y equaling a -4 and y equaling a +3, don't I? But I have to remember, y took the place of 2 to the x. So I've got to replace that back again. And here's where we go from there. Now I've got this line, and here's my final solution. So, you could have almost done a simple substitution technique and put a y instead. But understand, this is still a second degree equation. Y, my variable was 2 to the power of x. It was squared on the first term, it was to the first power on the second term. And then I had a constant. Cool? Okay, hang in there. I've got some more problems for us to work on like this one. Okay, so let's take a look at this third example. Do you notice I have a power of 2x and I also have a power of 1x? And it's equal to 0, isn't it? Does this problem look familiar? It kind of looks like the last one, doesn't it? It kind of looks like a second degree equation, doesn't it? But you have to know what your variable is. What's your variable? Yeah, your variable is 3 to the power of x. Because if I take 3 to the power of x, it's squared on the first term, isn't it? And in the middle one, I've got 3 to the power of x, and it's to the power of 1 on the second term, correct? And then I've got a -2, don't I? Right? Okay. So, here's the deal. I either get to use the quadratic formula on it or I get to factor it. Now remember, visualize, there's a 1 here and a 1 here, isn't there? If you use your magic X, and some of you maybe not use this magic X, but you have to multiply to a -2 and add to a -1, don't you? All right, so here's the thing. This will factor. What's my variable again? That's right, 3 to the power of x is my variable. And the question is, what two numbers will multiply to a -2 and at the same time add to a -1? Yep, I heard you guys. A -2 and a +1 will multiply to a -2 and add to a -1, won't they? All right. And after you factor, that's right, you set them both equal to 0. And then you solve. So let's just finish this one and solve. And I need to solve for x, so what do I have to do? That's right, you've got to take the log base 3 to get rid of the exponential base 3, don't you? Which will leave us x equaling log base 3 of 2. And is that a good answer? Yes, it is, because I'm taking a log of a positive number, so that'll be good. This second one, I have 3 to the power of x equaling, +1 equaling 0. I have to move the 1 over. And now I need to get that base of 3 out of there, don't I? How do I do it? Good. I have to take the log base 3 on both sides, which means on the left I just get x, and on the right I get log base 3 of a -1. Is that a viable answer? Nope, it's not, because I can't take the log of a -1. So right here is my only answer. And again, some of you are like, I like it better if I could write something else instead of 3 to the x. Well, that's fine. Then write y to the second minus y to the first minus the 2 equals 0, and then solve, and we'll get the same answer. Are you with me? Okay, hang in there. I got another. Okay, so let's take a look at this next example. It almost looks like the last one, doesn't it? I have a 3 to the 2x, but the middle isn't just 3 to the x, is it? It's 3 to the x plus 1, right? And then I've got minus 4. It's this middle that's throwing me off, isn't it? Okay, so let me give you an example. And this example will help us because we actually know how to do this, but we got to work backwards. So let me sidetrack you a second. If I had a to the power of 2 times a to the power of 3, since the bases are the same, what do you get to do with those exponents? That's right, you get to add them, don't you? So you get a to the 2 plus 3, wouldn't you? Okay, now here's the deal. If they gave me this, I could go backwards to this multiplication problem, couldn't I? So, this 3 to the x plus 1 is like this a to the 2 plus 3. This means that I had two bases, both of them were 3's. There was multiplication between them. One of these 3's had a power of x, and just like this has the 2. The other base had a power of 1, just like this one had the 3. And since the bases were the same, you added. Since these bases are the same, I could add and get x plus 1, couldn't I? So in actuality, this problem could be rewritten as 3 to the 2x plus 3 to the power of 1 times 3 to the power of x minus 4 equaling 0. This is the real problem we are working with. This is the real problem we are working with. My variable is still 3 to the power of x. And some of you would benefit from writing this next line. Your variable is still 3 to the power of x. And it's squared on the first one. The second one happens to have a coefficient of 3. And I have 3 to the power of x with a 1 outside that parenthesis, and then minus 4 equaling 0. This problem is just like the last one, except this plus 1 hid the coefficient of 3, and I had to undo it to get back to the original multiplication problem. Because now, that magic x that some of you learned, you have to multiply to a negative 4, but you have to add to a positive 3 because my coefficient in the middle is a positive 3. Are you guys with me? Okay, so this will factor, right? Because we know two numbers that multiply to a negative 4 and add to a positive 3, don't we? Good. So again, your variable is 3 to the x. I need a positive 4 and a negative 1 to multiply to a negative 4 and add to a positive 3, don't I? Excellent. And then we get to set each one of these equal to 0 and solve. So I'm going to take the first one and start solving. Based upon the last two examples, can you see what's going to happen here? Yeah, it equals a negative number. You have to take the log on both sides, don't you? Log base what? Good, log base 3, because I'm trying to get rid of an exponential base 3, which means you would have x equaling log base 3 of a negative 4. Is that going to work? Nope. That happened the last two times, didn't it? You know, sometimes that happens, and it happens a good majority of the time. And sometimes both answers work. And sometimes both answers don't work. So, you know, take each one individually. Don't assume that when you do these, you're always going to have one answer that cancels out because it doesn't work. Both of them may not work, and both of them might work. Take them individually. Take each problem for its own value. Okay, so we have 3 to the x minus 1. You know you've got to move the 1 over. Aha, you pretty much know what's going to happen here, don't you? Good. So you have... sorry, I am going to rewrite that. You have x equaling log base 3 of 1, don't you? And log base 3 of 1. Yeah, in this case, x equals 0. X is an integer. X equals 0 on that one. And you're like, how do you know that? That was from a previous lecture. Okay, good. Now, for those of you who are like, I don't like this 3 to the power of x as a variable, then fine, rewrite it. This is y squared, isn't it? Plus 3, the coefficient, times y to the power of 1 minus 4 equaling 0. And I'll end up with these answers here. Cool? Hang in there. I got another brain teaser. Okay, so let's take a look at this next one. So, couple of things going on. You're noticing this is a 25 to the x. But in the middle, you notice you have a 5 to the x, don't you? So, based upon the last 3 problems, these bases need to be the same, don't they? So considering this one's a 5 and this one's a 25, you could probably rewrite the 25, couldn't you? 25 can be rewritten as what? Good, 5 to the second. So here's what I just heard you say. I could rewrite 25 as 5 to the second, still raised to the power of x, with me? Which means I get to multiply those two powers, don't I? So this is really 5 to the power of 2x, isn't it? Minus 8 times 5 to the power of 1x equaling negative 16. Do you agree? So it almost looks like the last 3 that we've worked on. All we had to do was rewrite the 25, and now everything's kind of matching up. So I do have a second degree equation, don't I? But the second degree equations need to be equal to what number? They need to be equal to 0. This one's equal to a negative 16. So what else do we have to do? Correct, we have to move that 16 over. So when we move it over, whoops, we're going to add the 16 over to both sides. Good. And again, some of you may actually like this written, so you can see the variable is 5 to the x, and it is squared on the first one. And you can see your middle coefficient is an 8 of my variable, and then you're adding 16. Okay, so when you factor it, what's your variable again? Good, your variable is 5 to the power of x, isn't it? So I need two numbers that multiply to 16 and add to a negative 8. What would those two numbers be? Right, negative 4 times negative 4 is a positive 16, and that adds to a negative 8, doesn't it? Excellent. And so, hey, they're both the same. So how many problems do I really have to solve? Just one. Yay! Okay, so we are going to take this 5, and I'm going to write it up here. Why? Because I have more room. We're going to take this 5 to the power of x minus 4, equal it to 0. You know you have to move the 4 over, and you're going to have to take the log base, that's right, log base 5 on both sides. So, we're taking the log base 5 of a positive number, aren't we? So we're good here, aren't we? We have two of these exact same answers because I had two factors that were exactly the same. Agreed? Okay. And again, some of you may actually benefit after we've changed this 25 to a 5 to the second and we get to this point. Some of you may benefit from writing this, actually on this line, as y to the power of 2 minus 8y to the power of 1 plus 16 equaling 0. And you will have to go back to the original variable of 5 to the x to solve it. But you get the exact same answer. Good? Got one more brain teaser for us. Okay, so let's take a look at this last one. There's a lot going on here. First thing you have to do is identify that variable, right? Do you see it? Good. Some of you said, yes, I see it. It is the 7 to the power of x, because this has a 1x in front of it. But I'm noticing this is a 49, which means that 49 needs to be turned into a what? Good, it needs to be turned into a base 7, doesn't it? So we'll have 2 times 7 squared, right? Because that's 49, to the power of x plus 11 times 7 to the x plus 5 equaling 0. Agreed? And what do you do between parentheses? You multiply. So I have 2 times 7 to the 2x plus 11 times 7 to the 1x plus 5 equaling 0. Right? Okay. And this is where some of you are like, really? I really don't want to see all that. Okay. So what's my variable again? Good. 7 to the x. So for some of you, there's a 2 as my coefficient. My variable is 7 to the x, so basically I have y squared here, don't I? Plus 11 times y to the power of 1 plus that 5 equaling 0. Agreed? Some of you may want to factor this one instead. Regardless, you're going to get the same thing. So I'm going to go back here. You guys work on that one, and that's fine because we're going to end up at the same place. So what I'm noticing is, let's see. And if you do that magic X, some of you are like, well, I need a 10 and make it to an 11. That's true, and you got to do all the, what's the word I'm looking for? All the grouping, right? Because you substituted in for the 11. So, FYI. So, it's 2 times my variable and 1 times my variable. And I'm going to add a 5 here and add a 1 here. Let's see if that matches up with what you guys did over here. Over here, if you factored it, you got 2y and then the y, and you added 5, added 1. That gives you the exact same thing we have. Cool? Okay, so if you're having a little bit of a challenge factoring, go back to a lecture on factoring these trinomials when the lead coefficient is not a 1, because that requires a little bit of extra work. So, let's go back here. After we factor, we set each of them equal to 0, don't we? So I have 2 times my variable plus 1 equaling 0. I got to get my variable by itself, so I'm going to move over that 1, and I have to divide by that 2. Okay, can you see what's going to happen here? Yeah, you have to take the log of both sides, log base 7 of both sides, so you're going to end up taking the log base 7 of a negative number. Is that a viable answer? Nope. It's not. This one's not going to work for us. So let's go over to here. Okay, and equals it. Whoa, dear. The same thing, huh? I am going to end up taking the log base 7 of a negative number. Is that working for us? No, neither is that one working. So I had 2 solutions. Both of them are taking the log of a negative number. I can't do that. So what can you tell me about my solutions for this problem? Yep, this problem has no solution to it. Remember what I mentioned. Both solutions could work. Both could not work. One could work. One may not work. So you can't ever say, well, it's always one working, one not working. Not always. We have a problem right here where they both didn't work for us. Good? Okay, so you have fun with these brain teasers and I'll